Good evening, everyone. Let's start with today's session. So, let me share my screen. Can you see my screen?
Yeah,
Okay, so let's start with the ninth session for the course Basic Environmental Engineering, Pollution and Abatement. So far we had discussed about water pollution treatment, wastewater treatment, in which we had talked about primary, secondary, and tertiary methods. And we all know that depending on the type of treatment, may it be municipal wastewater treatment or may it be industrial wastewater treatment, or any industry can have generation of large quantities of solid. So let me take a slide. Okay. So solids are generated from any sort of industrial process. Then it can be generated from wastewater treatment, either industrial or it can be municipal or sewage treatment. So solids are generated in all these type of processes, and we know that solid can also have uh, the pollutant. Say for example, if you have performed adsorption, heavy metal adsorption, or organic adsorption on some adsorbent. Okay, so now if you want to dispose this adsorbent, then it has heavy metal and organic or such pollutant. So what you have done, the toxicity has been transferred from water phase to this solid phase. Okay, so this now again will be toxic because um, it has heavy metals or some hazardous organics which cannot be directly disposed. So sludge is any sludge is mainly obtained, which is obtained from wastewater treatment plants. So sludge is mainly semi-solid slurry produced from industrial process, water treatment, on-site sanitation systems, etc. So this sludge will have water along with solids. Okay, so now to recover the water and also to uh, remove the hazardous uh, pollutants from this solid, we need to do sludge management. So here we are just talking about the solids which are generated from wastewater treatment or some industrial process, right? So there can be, if we talk about wastewater treatment plant, then sludge or the slurry of solid and water, it can be generated from any of the steps like primary treatment, secondary treatment, tertiary treatment. And so depending on the treatment type, may it be primary, secondary, or tertiary, we have divided the type of sludge as primary sludge, secondary sludge, or mixed sludge, which is generated from uh, primary and secondary sludge, like it is a mixture. And tertiary sludge is nothing but the ones which is generated from tertiary treatment. So here are the methods of primary treatment. Say, for example, if uh, you perform sedimentation of the suspended core suspended solids. So sedimentation of coarse suspended solids. If you do, then whatever the solids that are recovered or the slurry or the sludge that is recovered, it is classified as primary sludge. Now, secondary sludge is nothing but which is generated from mainly activated sludge process or any such biological treatment, right? So it is uh, microorganisms plus the undigested solids or the organic solids. Now, tertiary treatment can have, say, for example, adsorbent or um, such things. Now, there were important terminologies which, for example, specific gravity of sludge. So this is important. So it will help you how uh, you will handle the sludge, or needs to be some criteria before disposal. So this will specific gravity of sludge will help in this. Now, I have already mentioned that why do we need to have sludge management? Because it has contains uh, toxic or hazardous components which cannot be directly uh, disposed, or which can, if it enters into environment, then it can cause some hazards. Okay, so it cannot be directly uh, disposed to the environment. So what are the methods for sludge management? So firstly, there can be two types of sludge. If it is hazardous, then we need to take care of it in the form of some industrial methods, say for example, incineration or thermal methods. And if there are chances that like the sludge that is obtained, it contains some food waste or some organic biodegradable waste, then what we can do, we can have some biological treatment, or we can use it, like we can obviously pre-treat it and or modify it, and we can use it for some fertilizer application or in agriculture after adding nutrients and so on. So these two types of strategies can be used for sludge management, which is industrial and non-industrial method. Now, talking about the industrial method, then what is the first definition of sludge? It is having solid and water as well. Okay, so here sludge management will have two aims. Our aim is to reduce solid volume, then reduce the toxicity, if any, of solids, and recover the water, which is in purified or pure form, right? Now, why do we need to reduce the volume of solid? Because solid at the end will be dumped in some site. So if more solid is there, so more space will be required, and so it will be more costly. And we know that the amount of solid waste that is generated is increasing day by day. So, if we try to reduce the volume of solid that needs to be disposed, then overall the process becomes much disposal becomes much more easier and environment friendly. So we try to reduce the volume of solid, and also the toxicity of solid needs to be reduced. That is but obvious, and we recover the water so that it is lesser and lesser wasted. So, since these are the aims, so first step is to concentrate the sludge. Okay, so concentration of sludge is, what does that mean? So, concentration of concentration of anything, what it means that we increase the amount of solute per unit uh, solvent. Okay, so here solute is solid and solvent is water. Okay, so here we try to increase the amount of solid which is present per unit volume of water. So what will this result it will result in the recovery of water from sludge, and also later we can able to separate the solute. So sludge concentration can be um, performed by two ways, which is flotation and gravity thickening. Okay, so flotation is nothing but dissolved air flotation, where we try to recover some lightweight lightweight solids, or the ones which can be easily carried away by growth. Okay, so as we try to pass the air, the solids, few of the solids or tiny solids can be carried away by air, and it can be later scraped off from the top layer of water. So that is nothing but flotation. And second is gravity thickening. So gravity thickening is nothing but we allow, it is a kind of sedimentation where we allow some residence time, so that under the gravity pure water can be obtained from the top, and solids which are heavier, and have higher density, they will be collected at the bottom. So bottom will have okay, so in case of gravity thickening, there will be two layers, pure, like somewhat pure water, and um less water plus solid. So that does not mean that this will have just pure solid, but the amount of water will be relatively lesser as compared to feed. So now, once this is done, there are further few steps which includes digestion of solid. So digestion of solid involves, as I said, sludge can have organics. Okay, so if there is some organic solid present in your sludge, then you can have solid digestion, where it will be digested, or it will be converted into some acceptable form. Okay, convert into acceptable or stable form, which can later be even disposed into environment. Okay. Now, so these solid digestion, it handles which are easy to digest. Okay. Now, if there are some solids which are difficult to handle and they are not easily degradable, then what do? We have thermal hydrolysis for that, where we apply high temperatures and high pressure. So now high temperature and high pressure are the extreme conditions, and by applying extreme conditions, we we ensure that even difficult to degrade organics or some solids, they can be converted into some lower toxic forms, or some lower or suitable forms, which suitable forms to environment. Okay, and now if we talk about the characteristics of sludge, then sludge is usually having some charge, as I had mentioned you earlier during the initial of primary treatment of coagulation and flocculation. So pollutants are having some charge, and this charge make them difficult to come closer. So now the solids will not be able to come closer. So here what we do, we neutralize the charge of the solids or the sludge, and by doing that, what we do, we increase its weight, or we allow them to grow and form bigger flokes, which will be easier to settle. So here we prepare, allow bigger flocks to form, and hence easier to separate, right? So moving forward, next step, another type or next step for sludge management involves uh, again, if we want to recover water, then filtration and heating, they are um, the ways by which we can reduce the amount of water, okay, from the sludge. Okay, so filtration can be done by rotary drum vacuum filtration or horizontal belt filtration, filter plate or centrifuge. Okay, so here are the images of those. So first is rotary vacuum filter, where this is the drum, and here there will be filter attached. Okay, so now when it passes through this slurry, the on applying some pressure difference, so there will be inside some vacuum generated, which will cause the liquid or water to pass through this. Okay, so water will be able to pass through the filter while solid will not be able to pass, right? So solid will be deposited on this outer layer of filter, and again it will, so some residence time will be maintained, and that will result into accumulation of solid on the outer layer of filter, which is known as filter cake, and water will be filtered. Okay, so it will keep on rotating, and there will be a knife through which you can scrap the cake which is deposited, because if it keeps on increasing, if the thickness of this cake increases, then what will happen over the period of time, the efficiency of this filter, it will reduce. So we do not want that, and that is why we scrap the cake. Okay, and even the flux can reduce if the thickness of this filter cake increases. So this is the principle of rotary drum vacuum filtration. Then next is horizontal belt filtration. So if this is the feed, then it flows, like belt is a kind of conveyor which allows, or which gives the water a path to flow. Okay, and if this is the filter cloth, then by applying pressure difference, the water will be passing through the filter, and solid will retain on the filter. So this is how it continuously operates. Filter plate is this one, where we have alternate plates like this, and water, and there will be a filter attached to that plate. Now when water passes through this plates, or which are having filters, so between two plates, if water passes, uh, only water will be able to pass through the filter, and cake will be deposited between the two plates, because it will not be allowed to pass, right? So here there will be deposition of the solids in between two plates. And last is the centrifuge, where you provide high centrifugal force. Okay, and there will be a filter, so there will be a solid drum kind of thing which has a filter. Now, when you rotate that drum at a very high speed, so centrifugal force acting on water and solid, it will allow water to pass through the filter and retaining the solids on the filter media. So this is how filtration occurs, and you will be able to dewater or concentrate uh, the sludge. Now, another way, this was all about filtration. Now, another way of concentrating the sludge, or reducing or recovering the water content in the sludge, is by heat treatment, because water will be converted into vapors, right? So, evaporation is one such way of doing that, and there can be dryers. Okay, so water will be evaporated, that can be, and that evaporated water is obviously very pure, so that can be further taken into boilers also, or um, the steam can be further used in industry for any process, right? So that is how we recover the water by using dryers. So once this is done, uh, the solid which is now there, it has some toxic organics or some another pollutant. So depending on the characteristics of it, we can have two types of oxidation: incineration and wet air oxidation, right? So talking about wet air oxidation, in the presence of air, and sometimes we even give catalyst so that the reaction speeds up. So, in this process, what we do, we supply air from external, by external means, and we allow under high temperature of maybe 130 degree to 150 degree. At this much temperature and pressure, the oxidation of solids occur to form CO2, right? And it is since the reaction is exothermic, so initial during the initial phase only we need to supply external heat. After some time, it becomes self-sustained, and we do not need to supply any external heat. And obviously, the efficiency depends on the temperature maintained, pressure, the quality of air that you are supplying, the type and quantity of solids, etc. Now, further incineration can be performed, where it again occurs at a very high temperature, even higher than 150 degree, maybe 600, 700 or above it. And so by that, total water can be recovered and total solids can be converted into ash and CO2 or some, like it is totally destroyed. So that is nothing but incineration. So, whatever the amount of solid is left, even after all this process, um, that can be disposed, right? So, disposal can be in the form of open dumping, where it is just open land and we just dump it. Then there can be special landfill sites where um, a proper site is created for disposal of such solids, and they are covered so that further spread of pollution, if there is some toxicity present in the sludge, then further spread of that toxicity is not is prevented, and it can be even disposed into sea, which is now not used. So this was about industrial method. Now talking about another environment friendly method, which is non-industrial. So it is nothing but composting, where we try to digest or we try to and recover biogas or generate biogas, you can say, which can act as fuel. And also we can prepare fertilizers from it, which can be applied into agriculture. So here we can have vermicomposting and so on, which will help in not only generation of biogas, but also will be able to prepare fertilizers that can be applied into agriculture. Okay, or some of the barren lands can be even converted to some fertile land, even if they are not able to grow plants. So moving forward, uh, so if this lecture talked about the digestion or degradation of these solids, which has anaerobic digestion. Now, anaerobic digestion, as the name suggests, it requires microorganisms to break down biodegradable oxygen, and as the process is anaerobic, we do it in the absence of oxygen. So, since oxygen is not present, we will have CH4 and CO2 as the product, which are like final product, and CH4 is further used as fuel. So this kind of process, you can say it is a kind of process where you can generate biogas. So important feedstocks or the type of solids or sludge which are used for anaerobic digestion include energy crops, animal waste, industrial waste, sludge from wastewater treatment plants, etc. And these are the products where we can have biogas, hydrogen, whatever the solid which is left that can even be used as fertilizer, compost, and reusable water. Now, the steps which are involved in this anaerobic digestion that are nothing but hydrolysis, acetogenesis, and methanogenesis. So, talking about each step, hydrolysis is nothing but conversion of very complex molecules into some simpler molecules. Okay. Now, next step is once the simpler molecules are generated, so that are converted to some sort of fatty acids, and fatty acids even are long chain, right? So, further, acetogenesis results into conversion of these fatty acids into some sort of acetic acid or hydrogen or acetates, right? And lastly, this acetic acid or acetates, they are converted finally to methane and carbon dioxide. Now they are recovered and further they can be used for any application or generation of um, electricity as a fuel. Now, these are the factors which are affecting the digestion process, which includes solid content, what is the amount of carbon or and nitrogen in the solid, at what temperature you are doing the digestion, because here you supply microorganisms, right? So there will be one temperature at which the activity or the say, for example, you are using different types of microorganisms, then the activity of those microorganisms depend on the temperature. So you need to choose temperature wisely such that the activity of microorganisms is quite high. pH, retention time, how much time you are providing, the type of digester or the design of digester, the type of microorganisms, everything affects the digestion process. Now, the rate at which or the time which is required for this digestion out of all this process, you can say, so each will have some reaction rate. Each step has some reaction rate. Okay. So, if out of this process, there will be one major reaction which will be controlling, or you can say rate controlling step, which is the slowest step. So, slowest step determines the rate of reaction. Okay, so out of all the process, the one which is slowest will determine the rate of this entire process. Okay, and usually methanogenesis is found to be slowest, and it controls, or you can say it is the rate determining or rate controlling step. Uh, Now, out of different, there can be two types of digesters, depending on the design, which is low rate and high rate digester. Low rate means it requires more residence time because the rate at which digestion occurs, it is less, and high rate means you can have more efficiency within less contact time. So, this was all about sludge management. Okay, so do you have any doubts so far? Okay, so if not, Someone has written a question. I'm not able to get. Can you please tell? Okay, so let me move forward. So now, this was all about sludge management. So from now, we will be discussing different case studies, you can say. So, for example, as I had mentioned, that depending on the type of industry, the quality of wastewater or the pollutants which are present in wastewater or in air emission or in solids, it will be different. Okay, so the amount and the amount of wastewater generated, amount of air polluted air generated, sludge generated, it varies, and also the pollutants and its concentration in those varies, right? So we need to have some uh, specialized processes, or we need to have some special or redefine or redesign the process for a particular industry such that we get maximum efficiency. So, starting with this lecture, it started with industrial pollution control measures, and this all has been covered very in very detail, like emission control, effluent control, and solid management. But to have proper measures, we need to have good housekeeping, like there can be some spillage, and so to take care of all those, we need to have good housekeeping. Then there can be some regular inspection is required, so that everything is monitored. Then the working standards, standard operating procedure, and everything needs to be properly documented so that if any one wants to refer, then it will be easier. Okay, then there are proper color codings that need to be maintained. Like there can be some gas line, there can be some water line, there can be some chiller or chillant line. So depending on that, there are color codings in the industry. Okay, so that by just seeing, because the industrial process is many, it has much more complexity. Okay, so there can be n number of pipes, n number of reactors, right? So there will be different color codings depending on what is flowing through that, or what is occurring in that particular pipe or reactor. So such color coding has to be done properly so that anyone can understand that. Then another measure that needs to be taken care of is segregation of waste, may it be any waste, air, water, or sludge. So, if waste has different characteristics, so instead of mixing, we need to segregate it, because mixing will result into treatment of more quantity of waste. So that will obviously incorporate more energy requirement and more cost requirement. Even the area required for treatment of more volumes will be more. So segregation obviously helps. Then there are industries which operate on batch mode. So the consumption and production should be as per the government approval, because government has approved a certain emission limit. So if you produce more quantity, then obviously the amount of waste that can be produced will be more. And also, if you have some treatment plant, then suddenly if you increase the product formation, then the treatment plant which is designed for a particular capacity, then it will not be able to have proper treatment. So in that case, the disposal standards can also be, it will fail to be met. So we need to have proper consumption and production management. And also the flow sheet needs to be updated so that anyone, if he or she looks, then he gets the complete insight of the process. So now starting with different case studies. So depending on the type of wastewater which is generated and the type of pollutants or sludge which is generated, we have some alterations in the treatment process. So we will look into some of the industries where like which has some different strategies for wastewater treatment and some solid management or sludge management, or what is their strategy usually followed. Okay, so first case study which was discussed was the sugar industry, and this is the flow sheet where sugar production. So firstly, sugar cane is used, which is shredded and it is cut, and now it is passing through miller. So once it passes, there will be generation of certain juice which is collected, and it will obviously have some solid. And whatever the amount of solid which is left, it is known as bagasse. Now that bagasse can be sent to boiler and it can be used for generation of uh, steam and electricity. Now, this juice which is produced is of our concern. Now, this juice has majority of water and like it is very dilute. So, what we do further step is to remove certain solids which are present and certain impurities which are present by adding lime, and we concentrate this juice in the evaporators. Okay, so here it is the removal of some solids and certain impurities if they are present by adding lime and some sulfur dioxide, and later we pass it through evaporators to have concentrated juice. Further concentration results into generation of much more quantity of sugar and less water, which and sugar crystals are formed. So now sugar crystals can be recovered um, by allowing to pass it through a centrifuge, and later the sugar crystals can be dried in a dryer and it can be collected. So main sources of wastewater here are processed wastewater, cooling tower overflow, and evaporator tube cleaning. Okay, so these it is not advisable to mix all these streams, and it is always advisable to treat differently. So there was a different scheme of a series of primary, secondary, and tertiary treatment which has been followed for all this has been shown to you, right? And obviously the sludge can be uh, sludge which is generated in this process. It can be further used as fertilizer after drying it in drying bed or collecting these dry solid from the filter press. Now, since it is just a feedstock which has just sugar cane solid, so that is nothing but very environment friendly. So that can be further used for composting and so on. So now moving forward to the assignment. First question is the specific gravity of sludge. Sludge, which is nothing but water and solid, can be calculated by following. So it can be calculated as 1 upon solid fraction by sludge density, right, plus water fraction by density of water, which is nothing but 1 gram per cc. So this is the formula for calculation of specific gravity. Next question is digestion of sludge can help to dash. So if you look into the options, then reduce the total mass of solid, destroy the pathogens, make sludge easier to dewater. So all of the above is the correct answer because it will reduce the solids, like easy to digest solids. It can even at high temperature or so it can reduce the pathogens, and also now the sludge volume has reduced, so it is easier to dewater. So all the options are correct. Next is thermal hydrolysis followed by anaerobic digestion converts around dash percent of solid matter to liquid and gas. So it is a standard thumb rule, like majorly it gives 60 to 70% conversion. Next is which of the following, stop me if you have doubt anywhere, right? So, which of the given below statements is not true about the composting of biomass and waste? So, if we look into option, it employs natural aerobic degradation. So, composting is obviously natural aerobic degradation. Then it requires low energy.
Solar.
Yeah, so it do not require any external energy, but it requires large land area, which is not correctly mentioned here. So require small land area is the wrong option because you need to give high surface or high like large area so that it will have proper contact and so on. Now dash is the primary product produced in the anaerobic digestion of biomass and waste. So biogas is obviously one of the major product of anaerobic digestion. Then obviously fertilizer can be obtained. Bio oil is not obtained, or any sort of oil is not obtained from this sort of digestion. So this is not the product of anaerobic digestion. Obviously, we can recover the water. So bio oil is not the primary product. Next is identify suitable match for the feedstocks with typical hydrolysis product. Okay, so hydrolysis of carbohydrates result into alcohol. Okay, then cellulose will give you
Glucose.
yeah, glucose. Then proteins will give you amino acid,
Fat.
I guess. Okay, fats and glycerol, and peptides will give you amino acid. Sorry, amino acids. So yeah, this P3Q4 R2 and S1 is the correct answer. Next question is the theoretical substrate conversion rate per unit reactor volume can be estimated as dash. So this option is the correct answer, right? Where this is the concentration of substrate, and theta is the detention time. Rest are the constants. Low rate sludge digester requires detention time of, so this is theoretical estimation, and theoretically, like mostly it requires 30 to 60 days for digestion. Next question is in sugar industry, the mixture of sugar crystals and mother liquor is known as, uh, this is option B, massicute, after which you pass this entire mixture into the centrifuge where sugar crystals and mother liquor they are separated, and mother liquor can be further treated and recovered, and we can recover some byproducts if any. Next question is 300 cubic meter of mixed sludge at 8% solid is to be thickened to 15% solids, assuming specific gravity is not appreciably different from that of water, and it does not change during thickening. What is the approximate volume after thickening? So since here it is mentioned that specific gravity is not different from water and it is not changing, then in that case we can equate volume. So this is the process which is going on. And here there is some volume which is 300 meter cube which is entering, which has both solid plus water. Now the solid concentration is given to you as 8%. So here, since the basis is not given, you can consider this to be 8% solids, which is based on water or volume percent. So 8% of this volume will be the amount of solid. So you can say that 8 by 100 into 300 is the amount of solid, or you can say volume of solid here. And even you can say that the density of this sludge is same as water. So you can say density of water is nothing but 1 gram per cc. Okay. So the correlation between volume and mass will be same, right? So here you do not need to consider volume to mass conversion, because you can say that mass is always conserved and it can be added. M is always m1 plus m2, but you cannot always add or conserve volume. So here, since density remains constant, so you can have such conversion. Now, to have thickening occurring, we need to concentrate it, and 15% solids should be there. Okay. So here, what is the amount of solid? If you calculate, this is nothing but 24, right? So thickening can occur by removing water. Okay. So this can be done by evaporating water or any sort of thickening. Now, since you are separating water in pure form, this will have no solids. Okay. And this will have again solids plus water, but the amount of solid, or the concentration of solid increased right here. So what we need to do, we need to apply solid balance over this process. So let's say this is C1, this is C2, and C3, which is the concentration of solid in each of the process. This is V1, V2, and V3, right? So if we apply balance, then what should be that? Input should be equal to output, which is nothing but balance on solids. Now here you are able to use uh, this concentration. So input of mass of solid is nothing but 8% in, like, which is nothing but the concentration into the volume, right? Which is V1, this is C1. Output will be in the form of C3, V3. There are two outputs, plus C2, V2, right? Now C3, V3 will be 0 because there are no solids in this stream. Okay. So if you apply balance, or if you put up the values, 8 by 100, which is because percentage is here and volume is 300, is equals to, this will be 0, 0 plus Concentration here, which is required, is nothing but 15 by 100 because 15% is there. And volume you need to calculate, right? So if you solve this, V2 will come out to be 160 meter cube. I hope you are getting this. Are you able to calculate? Can anyone tell me if you are able to follow or you are able to calculate? Someone please tell me, or I will consider that you have understood. Um, and this was the last question for today.
Got it. Yes.
Sorry?
We got the answer 160.
Okay, you got. Okay.
Yeah.
And you understood the process, right?
Yeah.
Okay, so if you have any doubt other than this, you can tell me, or we can end this session for today.
Like in all terms, we can use this formula. Like we have to add this accumulation plus output is equals will become the total of input.
So, see, input equals to output for any continuous process, or input minus output equals to accumulation can be applied anywhere, but you have to apply it. You need to have mass balance.
Okay.
Okay, so here, since I am able to use this formula, because first assumption here should be 8%. It can be weight by volume, right? So in this manner, you can convert this term into mass. And another assumption that you can make is the density is same as water. Okay, so specific gravity is appreciably not different from water, which means that density is equals to water, water density, right? So here you can say that if you have 1 meter cube of volume, then you can have corresponding 1 kg of solid, right? Or 1 kg of weight of that water. So in this case, conversion will be same. But other than that, if the specific gravity is not same, then you need to convert this volume into mass by using density, and again you need to convert. So that sort of conversion you need to have if the specific gravity is not same as water.
Yeah. Okay.
Okay. Other than that, do you have any doubt?
No, not till now.
Okay. Yeah, so thank you everyone for joining. I am ending this meeting now. We will meet in
Yeah,
the next class. Thank you everyone.
thank you.